Okay guys, today we're going to be factoring. So we're going to start with GCF, which is greatest common factor, and then we'll go into trinomials and difference of squares, and then the next set of notes we'll go into some more factoring. So GCF, you always when you factor start with GCF just because it makes your life easier. So GCF stands for the greatest common factor, so what they have in common. So the first problem, I'm going to break it down for you, and then after that we'll just go with the pattern. So 3x squared is 3 times x times x. Yes? Okay. 27 is 9 times 3, but we can break down 9 into 3 times 3, so it's 3 times 3 times 3. Okay? So this is what I have, 3 times x plus 3 times 3 times 3. Factors are what we're multiplying, so which factor or factors do they have in common? They both have a 3 in common, so that's what's going to go outside the parenthesis, and then we have to put our parentheses, and what's left over is literally what's left over, what they didn't have in common. So they had a 3 in common, so what they have left over is x squared, and 3 times 3 is 9. Okay, so that's how you do that one, and that's really broken down. So a faster way to do this is something called the hockey stick method. So instead of having to break down each term into its components like we did here, you can draw like what a little hockey stick, the bottom of a hockey stick would look like, and say, okay, what do these have in common? They are both divisible by 3. And if I do 3x squared divided by 3, I would have an x squared left over. And if I do 27 divided by 3, I would have a 9 left over. So that 3 goes in front of the parenthesis, and then whatever's below the hockey stick goes in the parentheses. Okay? So we're going to move on to the next problem. We have a negative in front. So you can use hockey stick method, or you can use this method if this is what works best for you, or you can just do this. Okay, if they have a negative 5 in common, it goes out in front because both these numbers are divisible by negative 5. And then what about the x's? They both have an x squared in common because this is x times x times x, and this is x times x. So they both have at least 2 x's left in common. So what would go in the parentheses? Negative 5x cubed. Here's another way to look at it. Let me say it this way. Negative 5x squared times what would give me negative 5x cubed? So that would just be x, right? You can also look at it like this. Negative 5x cubed is this right here, and this is negative 5x squared. So cross out what you have, and what's left over is the x. Okay? So we're progressing beyond having to write all this out. This is 5 times 3, that's what 15 is. And then when I take the 5, it's actually a negative, so I have to put a minus here because this is a positive, and a negative times a negative is a positive. So you're going to have to be careful with that. And then that would be the 5, and the 2x is for the x squared, so I get x minus 3. So I think many of you are just going to like hockey stick method. So you know that you have negative 5x cubed plus 15x squared, and you're looking for the greatest common factor. In math, a factor times a factor equals a product. So this is our product right here. We're trying to figure out how to write it as a factor times a factor. So we look for what they have in common, which they have a negative 5x squared in common. And if I do negative 5x cubed divided by negative 5x squared, the negative 5's would cancel out, and 2 of the 3 x's would cancel out. So I'd have an x, and then 15 divided by negative 5 is negative 3, and x squared divided by x squared is 1. So you can see that right there. Okay, we're going to pick things up just a little bit because I think you guys can handle this. So on the next one, what do these have in common? Start with the numbers because that makes life easier for you. They're both divisible by 2, and they're both divisible by x. So 2x times what is 2x? You need the 1 there. That's a placeholder. 2x times what is 4xy? Well, we need a 2 because 2 times 2 is 4. We don't need any more x's because we already have the x, and we need a y. So you can always check your work by multiplying mentally in your head. So 2x times 1 is 2x, and 2x times negative 2y is negative 4xy. Okay? Moving on to the next guy. Ooh, mathematicians don't like having negatives in front, but for this problem we have to. So we're going to pull out a negative always. And then they also have an x in common. So they have a negative 3 in common and a negative x in common. So again, remember, if this is tough for you, I've given you 2 other ways to do this, but I'm pretty sure at this level, a lot of you are capable of this in your head. So negative 3x times what other factor will give me negative 3x squared? So that's just going to be an x. So if I do negative 3x times x, I get negative 3x squared. And if I do negative 3x times what is negative 24, so that's going to be positive 8. So again, if you'd like to, you can fall back on the hockey stick method. So that's GCF. So anytime you're given a problem that says factor, try and look for a GCF first. It makes your life easier. Next, we're going to be factoring trinomials, and we're trying to make this just a little less intense for you by making the leading coefficient here 1. Notice there's no other number there. You can write like a dotted 1 in there if you'd like, but you know mathematicians are lazy, so they're not going to do it. So, at Steel Canyon, we have a method of factoring trinomials. Notice trinomial means 3 terms. It also starts with a t, so when we factor trinomials, we do something called a t-chart. And the way it works is you take the highest power of x and put it here. Then you're going to come down to the bottom, and sometimes teachers even use circles. So I'll use them this one time. It's kind of more work to write the circles when you don't need to. The next power of x actually goes down below, and the last power of x goes right here. So the pattern, you have 3 patterns. You need to multiply whatever goes here and here to give you x squared. So this is really easy. It's just x times x, right? X times x is x squared. Great. What about 20? Well, for 20, you have lots of different things that make 20. You have 10 and 2. Yes. You have negative 10 and negative 2. That makes 20. You have 5 and 4 that make 20. You have negative 5 and negative 4 that make 20. You have 20 and 1 and negative 20 and 1. So how do you know which pairs of factors that make 20 go here? Well, that's where this guy comes into play. So you need to find 2 numbers that multiply to give you positive 20, but that add up to give you negative 9. So 10 and 2 would give me 20, but when I add those numbers, I get 12. When I add these numbers right here, I get negative 12. When I multiply these, I get 20. Great, but when I add them, I get positive 9. When I multiply these numbers, I get 20, because a negative times a negative is a positive. But when I add them up, I get negative 9. So those are the numbers that I'm going to choose. These ones aren't going to work. And you can always check your work, because this is negative 5x when I multiply these. And when I cross multiply these, I get negative 4x. And they have to add up. So here's the pattern for t-charts. Multiply up to get this number, multiply up to get your constant. You always have to cross multiply and add those 2 numbers to get that middle term. Okay? So the way this factors is this term, which is x minus 5, and this term, which is x minus 4. Okay? So you guys have probably seen this before. It's not new. We're just practicing it again. So I'm going to speed it up a little bit. If this is new for you, I will find some other videos for you to watch so that you can do this. So this is x and x, and then they need to multiply to be negative 12. So you're always multiplying. So I have 6 and negative 2, or I have negative 6 and positive 2. Or I have 12 and negative 1, or negative 12 and 1, or 4 and negative 3, or negative 3 and 4. And I believe those are all the factors that make 12. You don't have to write these all out. If you've got it in your brain, what's going to be the answer, then use it. So this is what I do. Automatically, all these guys are eliminated because when I add them up, they're not going to give me 4. Now I have to choose between these two. Because this number is positive, the numbers I put here, because this one is positive, the bigger number should be positive. Okay, so I'm going to double check my answer. Cross multiply, I got 6x. Cross multiply, I got negative 2x. And when I add 6x plus negative 2x, I get 4x. So I get x plus 6 and x minus 2. So keep in mind, you can always check your work on these on the test. You guys have plenty of time on test days to check your work. So what do you mean by that? I want you to do the 6.2 lesson if you have time, and you would FOIL these or box method these and make sure you get this answer. So in math, this is called standard form because it starts with the highest power of x and it goes down. And this is called factored form because right here you're taking two binomials and multiplying them together. These are the factors, this is the product. Alright, let's try the next one. I'm not going to spell it out as much for you guys because I know you've got this. So right away, I know this is x and x, and then I also know that I have more negatives than positives. So I have more negative x's than positive x's. So when I pick my numbers here, I'm going to make sure that my negative is the bigger one. So I have 9 and 2, so if I do 9 and negative 2, that's not going to make 3. 18 and 1, 18 and negative 1 is not going to make 3. But 6, but I'm actually going to pick negative 6 and positive 3. So you can even put a positive there, so like I could go back to these and put that positive 6 just to help you with writing your factors. It's going to be x minus 6 times x plus 3. Alrighty, now we're going to move on. We're going to go up to problem D. So D is x squared plus 12x plus 36. So same thing, x squared, 12x, 36, x and x. And then what two numbers make multiply to give me 36 and add to give me 12? So 36 and 1, no. They're both positive, so I actually know, since this is positive and this is positive, that both of those numbers are going to be positive. What about 6 and 6? Doesn't that work? Yep. So I get x plus 6 times x plus 6. Now, these are the exact same thing, so if you want to be fancy, you can write it like that. Okay? Alrighty, let's move on to this one. Ooh, 63. That's okay. X and x. And then we have negative 63. But I have more positives. So a negative times a positive is going to give me the negative. But because I have more positives, I should make sure my positive number is bigger. So I'm familiar with my multiplication. So I know 9 times negative 7 is negative 63. And then when I do this, that 9x and that negative 7x add to give me 2x. If you're not doing this step, like I didn't do it up here because I kind of did it in my head, but you should definitely be doing this step because you have to check to make that these two cross multiplication numbers add up to give you that. Otherwise, it's not going to happen for you. So we have x plus 9 times x minus 7. Alrighty? So now we're moving on to another form of factoring. So let's just revisit, take a break for just 2 seconds and revisit what we've done. We've done GCF, which is the greatest common factor. So we factored out terms from each of these. Then we went into T-charts or trinomials. So when you factor a trinomial, your skill is to T-chart. GCF, you can use hockey stick or another method. The next type of factoring, which is one of my faves, is the difference of squares. And a difference of squares says this: if you have a perfect square, like a squared, and you subtract b squared, so a difference of, and if you want to write, you can write that word right there, perfect squares. That just means like 25, 9, 16. If you want to make a list of your perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9. Most of you know these, so that's why we don't have them written on here. But maybe you need a quick refresher, so I am writing them out right here. What's the biggest one? Oh, we got a 9 squared. So we'll stop at 10, right? Those are all your perfect squares. So if you're subtracting 2 perfect squares, rather than having to make a t-chart, you are guaranteed that this is going to factor to a really cool pattern. Both terms are going to have an a and b in them. So if I want to know what a is, I just square root a. And if I want to know what b is, I just square root b. The only thing is that there's going to be a plus and there's going to be a minus between your two factors. The reason why this works, let's take a look at it. A times a is a squared. A times negative b is negative ab. Plus ba minus b squared. AB and BA are like terms. Even though their order is different, it doesn't matter, but this one's negative and this one's positive, so those cancel out, and I get a squared minus b squared. And that will always happen when you have a difference of perfect squares. Okay, so let's take a look at this. Instead of having a squared minus b squared, we have x squared minus 25. So the way this is going to factor is, what's the square root of x squared? X and x. What's the square root of 25? 5 and 5, and there'll be a plus or minus in between them. That's it, guys. You got this. What about the next one? You have to check to make sure they're a perfect square. How are you going to know it's not one of these t-charting things like we did before? How many terms do we have? We have 3. How many terms do we have here? We have 2. Now what about if it's a GCF? Do they have anything in common? Does 4x squared and 9 have anything in common? No. Now we know it's not a trinomial, so we're going to check for a difference of perfect squares. So 4x squared. 4x squared, if I square root that, the square root of 4 is 2, and the square root of x squared is x. So the first term in each set of parentheses is 2x. Square root of 9 is 3 and 3, and then I just put a plus and a minus in between them. Okay? Moving on to the next one, I have 9x squared minus 16. It doesn't have 3 terms, so I'm not going to t-chart. And there's no GCF, so 9x squared and 16 don't have any common factors. So I'm going to do my a squared minus b squared equals a plus b times a minus b. Square root of 9x squared is 3x, so the first term is 3x. Square root of 16 is 4, and I need to put a plus and a minus in between them. So when I FOIL it out, that middle term will always cancel, just like we did there. Wow, math is magical. Oh no, we have an x squared and a y squared. It's okay, guys, they're perfect squares. So, same thing. Square root of x squared is just x. Square root of 81 is 9, and square root of y squared is y. And then put a plus or minus in between them. Not too bad. Last problem. Let's handle this. Square root of 25x squared. Square root of 25 is 5. Square root of x squared is x. First term in each set of parentheses is that, according to the pattern. Second one, 9y squared. So we have 3y and 3y. And put a plus or minus in between them. Now, I want to tell you guys, this is the way that I teach this lesson on factoring. If you go to the SCHS Cougars Math website, Miss Yosh has also recorded a video. Maybe you like the way she teaches it. As long as you're picking up what we're putting down, I don't mind if you watch another teacher's lesson. In fact, I encourage it. I want you to take ownership for your education. Be responsible. If you don't understand what I'm doing, is it really that big of a deal to take 20 minutes and go watch another teacher's video? No, and I know you can do it. So please, 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 please take advantage of the resources that we're giving you and go watch other videos if you need them. Okay, so now we're on to the back side and we're going to be factoring trinomials again, but this time the leading coefficient isn't 1, it's some other number. So, come on guys, this will be a little better hopefully. Alright, that's a little better. So for this particular one, it's the same thing. Anytime it has 3 terms, you're going to t-chart. So let's set that up. 3x squared, 20x minus 7. So 3x squared, the only way we can make 3x squared is 3x and x, right? Okay. And then what we're going to do is figure out how to multiply to get negative 7, but when I cross multiply, I get positive 20. Oh my gosh. Now be careful, this one's a little trickier because we have to cross multiply and it's not just x, we have 3x. So this one is actually going to be 7 and this is going to be negative 3. And how do I know? Well, that doesn't actually make sense because this is negative 3 and 7 times negative 3 does not make negative 7. Now does it? So even I make mistakes sometimes and that's okay. I realized it right then. So what I'm going to do, just go ahead and wipe that out and write a negative 1. Okay, so 7x times 3x is 21x and it's positive. And x times negative 1 is negative 1x. When I add those together, I get 20x. I'm going to put a plus next to that 7 just as a friendly reminder. 3x minus 1 times x plus 7. Alrighty, moving on up. Okay, now we're at this guy right here, 5x squared minus 17x plus 6. So 5x squared minus 17x plus 6. So 5x and x. I'm noticing I have more negatives down here, but this is a positive. The only way I can have this be negative and this be positive is if both these numbers are negative, because a negative times a negative is a positive, but when I cross multiply, those numbers will both be negative, and when I combine like terms, they'll stay negative. So what makes 6? 6 and 1. If I put a 6 here and a 1 here, don't write it yet, I'm trying to prove a point. This is negative 5x, and this is negative 6x. And negative 6 and negative 5 make negative 11, not negative 17. So this is not the correct factoring for this problem. So what if I switch it around? You could switch it around and do negative 6 and 1. This would be negative 30x, and that would be negative 1x. Negative 1 and negative 30 does not make negative 17. Oh my goodness, it's okay. You don't have unlimited possibilities here. There's only a certain set of numbers that multiply to give you 6. So I'm going to try negative 2 and negative 3. Negative 5x times negative 3 is negative 15x, and negative 2x times x is negative 2x, and negative 2 and negative 15 makes negative 17. So you might have to do a little guess and check. But you're like, that's cool, Woken. I can handle multiplication, so it's no big deal. All right. Next one, 4x squared plus 12x plus 5. Let's do that real quick. So at a certain point, these just get repetitive. Now, with this particular one, when I go to do 4x squared, I can try 4x squared and x, but... Sorry, not 4x squared, just 4x and x, because when I do 4x times x, I get x squared. But I can also try 2x and x. So just know that depending on what this number is, you might have more than one option. When I had 5x squared, that's just 5 times 1. That's the only thing that makes 5. But with 4, it could be 2 times 2 or 4 times 1. So you just have to guess and check, and then I'm trying to get 5, so I can get 5 and 1, and this is the way you always check your math. Cross multiply and add, so that works. So at this point, if you're feeling like, okay, I get this, you should probably just pause the video and start working. I'm going to keep going through until we get to the next example and just keep kind of explaining, but I really encourage you guys at this point to start pausing the video so that you can practice on your own so your brain learns. So I have 7x and x. Both of these numbers are negative, so one of these is going to be positive and one of these is going to be negative. That's the only way I'm going to get a negative here. But I want more negatives than positives, so it's probably going to be like that. Once you start practicing these more, you get pretty good at guessing. So they're educated guesses. So, but if that doesn't come to you, if you just don't see that, it's okay, because you just guess and check until you get it right. All right, 4x squared. Whenever I see like a 4 or a 6, I'm kind of like, I'm going to have to do a little more work. When it's 7x squared, that's the only option. 7 times 1 is 7. But 4x squared, I have other options. So I'm going to start with 2x and 2x and then see what I can get. This is a positive 49, so both of those have to be negative, because if this is a positive 49 but my x term is negative, the only way I'm going to get that to be negative is if these are negative when I cross multiply, and the only way that's going to be positive is from multiplying that. 7 times 7. I hope it's rigged. Yay! Negative 14x plus negative 14x is negative 28x. So 2x minus 7 times 2x minus 7. And you can be fancy and write it as 2x minus 7 squared if you want. This is a perfectly good answer for me though. So if you want to be fancy, you can. 2x, oops, that's 4x squared, not 2x squared. 4x squared, 20x, 25, 2x, and 2x. Hopefully it's just 5 and 5. Does that work? They're both positive, so I don't even have to worry. Yep, great. 2x plus 5 times 2x plus 5, and that's 2x plus 5 squared. Great. Okay. So, the very last example in this lesson, which goes all the way to F, is combining the GCF with the other things that you've learned. So, like I said from the beginning, always GCF first. The problems that we gave you in this entire section right here don't have any GCF because we wanted to first practice the skill of T-charting. Now we're going to GCF and T-chart, or GCF and difference of squares, etc. So look at a problem and always hockey stick or GCF first. So I see that both of those are divisible by 5, so I get to that. But then I'm going to look at here, because there's only 2 terms, I can check for a perfect square. This is a perfect square and that's a perfect square, so I have a difference of squares. So that's what we practice on the front side. So with a difference of squares, you take the square root of that, it's x, and the square root of that, which is 3. And then, sorry, you have a plus or minus between them. So if I were to multiply this out, I would get x squared minus 9, and then I would distribute the 5, and I would get that right there. Alrighty, let's go look up here. Oh, I have 3 terms, so your gut may tell you to T-chart, but you're absolutely going to notice that these are all divisible by 5. So I'm going to factor out that 5 because it makes my life easier, okay? And then I'm going to T-chart just this piece. Okay, so x squared minus 4x plus 4. X times x multiplies up to give me x squared. And I'm noticing that I have a positive 4 here, but a negative here. So these are going to be negative. So negative 2 times negative 2 is 4. and negative 2x and negative 2x add to give me negative 4x. So I'm going to carry down that 5, but I can factor this more into x minus 2 times x minus 2. And if you want to be really fancy, you can write it like that. Alright, so then I notice that both of these are perfect squares, but I'm going to be really careful because 4 and 36 have a common factor of 4. So it looks like this, right? And then, because these have two perfect squares, I can use that difference of squares pattern. X and x, 3y, 3y, plus or minus in between them. And that's it. There's no fancy way to write that. If you have a plus and a minus, that's the only way you can write it. I do want to show you guys this real quick. If you were to do this, 2x plus 6y times 2x minus 6y, do you guys notice that both of these terms, 2 and 6, are divisible by 2? I could factor that at GCF out, and 2x minus 6y are also divisible by 2. So do you see my x plus 3y and x minus 3y there, but I have a 4? Well, what's 2 times 2? Remember in math, if you have 2 times 3 times 4, that's the same thing as 3 times 4 times 2. You can change the order when you're multiplying. It doesn't matter. They both equal the same thing. So if I put the 2 times 2 next to each other, that would give me 4. And then I can't simplify these factors, so they stay the same. Okay? Whenever you have a negative, if you can factor it out, you don't have to, but it makes your life easier. So I'm going to factor out a negative 2. When I do negative 16 divided by negative 2, it's going to give me a positive 8, and because it had an x, it's still going to have an x, and this is a positive 16. So then I'm going to take this, I'm going to t-chart it over here, right? Double check 4x and 4x. So I'm going to do my math real quick. X times x is x squared. 4 times 4 is 16. Cross, multiply, and add gives me 8x. Okay? So negative 2 times x plus 4 times x plus 4. And that's actually negative 2 times x plus 4 quantity squared. So anytime we have something in parentheses, we say quantity, so that whoever is listening to you knows that. They know what you mean when you say quantity. Alright, 3x squared, 18x, and 15. Those are all divisible by 3. So that's what's left over. And then I'm going to t-chart that. So I'm going to carry the 3 down. And everything's positive. So, and this one's kind of an easy t-chart, right? Because the only thing that can make x squared is x times x, and the only thing that can make 5 is 1 and 5. Cross multiply, x plus 5x is 6x. So you get that right there. If you were to t-chart, you could t-chart this without, but one of your factors, you can t-chart this without doing the GCF, but one of your factors would contain a 3, which means it wouldn't be completely factored. So I'm going to show you that real quick. So 3x squared, 18x, and 15. So you know 3x and x, and then 5 and 3. Because that makes 15x, and that makes 3x, and when you add those you get 18. So that would be 3x plus 3 times x plus 5. So there's no common factors in that one, but 3x and 3 both have a 3 in it, so you could pull that out from just that factor, and it would look like that. And if you notice, it's the exact same factors there and there. Okay? So you don't necessarily have to do GCF first, because sometimes students don't see the GCF, But if you get to an answer and you notice your factors have a common factor, you haven't finished yet. You need to factor out the common factor. All right, this one's divisible by -3. So then you get to that right there. So you can always double check your work. -3 times 3x squared is -9x squared. -3 times +10 is -30. And -3 times -8 is +24. Then I have 3 terms here. So I'm going to try and factor it. By the way, we've kind of rigged the problems for you to be able to factor them. But in the whole world of math, you don't have to be able to factor them. If they're not factorable, they're called prime, just like when numbers are not factorable. So -2x and 12x makes 10x. So I get 3x minus 2 times x plus 4.